कौन से स्पॉटलाइट में आता है?
अच्छा स्पॉटलाइट को इसको स्पॉटलाइट किया है
इसको है ना काटे ये चाहिए देख प्रेजेंटेशन फुल इस प्रेजेंटेशन ना প্রেজেন্টেশন হবে শুধু এটা না শুধু এটা তো একটু খুলে দিস এটা ওটা খুলে যেটা রেজিস্টার চলবে তো ওটাই সেম 22 তারিখ এটা বলছি যেটা লিখেছি हेलो 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 सारे माइक ऑफ है माइक ऑफ है आज ठीक है चल कंडक्टर सबसे पहले प्रेजेंटेशन खोलो उसकी एक मिनट सर की प्रेजेंटेशन कर रहा हूँ ठीक है सर वाले बंद कर रहा हूँ ये रहेगी और अब देखना उसमें क्या आ रहा है मैं अनम्यूट कर रहा हूँ इसमें ये क्या आ रहा है हाँ एमएसटी में नहीं आएगा ऑनलाइन में जाएगा ऑनलाइन में आ रहा है ना देखो आवाज देखो हाँ ऑन है ये हाँ ऑन है ऑन नहीं है ऑन है हेलो हेलो हाँ ऑन है आवाज कम है आवाज आ रही है चेक करो उसमें ठीक है और ये वाला स्पॉटलाइट में आ रहा है ना इसमें भी वही कर रहे हैं हाँ सबसे हाँ क्या हाँ उसी सेटिंग्स डिवाइस सेटिंग्स जो नीचे वाला जो अरे ये टास्क इसको फ्रीज क्यों हुआ और ये अभी लाइव है कुछ पता अभी लाइव ही चल रहा है देखो वो ये इसमें बाय डिफॉल्ट मिनिमस कर देना है बाय डिफॉल्ट यही रहेगा मिनिमस कर देना है और फिर वो ऑन कर देना है स्पॉटलाइट फ्रीज क्यों हुआ किसने अभी हो गया चल गया ना ये लगा चला के जो ये भी कर लेता ये वाला रहेगा जब लोग आगे डाइस पे बैठ जाएंगे तो मिनिमाइज करके इसको स्पॉटलाइट
Voy a slice roso. Sepon. Hey, Mr. Mic check करना है तो
আপনি বলুন। আপনি বাইরে যান, এই তো হবে হবে না।
হ্যালো অনুমাদি, হ্যালো
হ্যালো।
হ্যালো হ্যালো,
হ্যালো, শুনতে পাচ্ছ? হ্যালো,
শোনা যাচ্ছে?
শুনতে পাচ্ছ?
হ্যাঁ শুনতে পাচ্ছি।
ভিডিও দেখতে পাচ্ছ?
হ্যাঁ দেখতে পাচ্ছি।
ঠিক আছে,
ঠিক
ওকে
আছে ঠিক আছে।
ওকে।
হাই করা যাবে, ক্যামেরাতে ডাইরেক্ট সাউন্ড আসছে তো একটু কম আসছে।
তিনজন হয়ে গেল এখন? তিনজন হয়ে গেলে তো ওখানেই হয়ে যেতে পারতো।
সুস্মিতা, সুস্মিতা কোথায় গো? হ্যাঁ হ্যাঁ, সুস্মিতা লাস্টে কালকে বলে দিয়েছিল। হবে না। हेलो, ठीक है। তুমি ডাক্তারকে বলো না, আমি কাজে ব্যস্ত আছি। তুমি কি বলিস বলতো? ফোন করতো। হ্যাঁ বল। আমি এখন যেতে পারছি না, ডিরেক্টর সেলে কেন আসি? আমি ডিরেক্টর সেলে আছি এখন দেখবেন। আমাদের যতটা মানে ততটা পারবো। এটাকে নামিয়ে দেবো, এটাকে আচ্ছা বলুন। যখন মেন ছিল না
চেষ্টা করো, ওই যে চ্যাটটা বললাম স্যার পার্টিসিপেন্টস
হ্যাঁ।
দেখা স্ক্রিন ছোট হয়ে গেছে।
হ্যালো 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 হ্যালো, ঠিক আছে অ্যাডজাস্ট করে দিই। হ্যালো চেক, হ্যালো হ্যালো চেক, হ্যালো 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 চেক, হ্যালো 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 চেক, হ্যালো 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 চেক, চেক হ্যালো। ও আচ্ছা আচ্ছা আচ্ছা, বুঝেছি বুঝেছি। ঠিক আছে, আমি পেরেছি। ঠিক আছে। Good morning. Good morning to online participants. Are you able to hear me? Anybody online can kindly answer.
Yes,
Yes,
sir.
yes, you're audible.
Hearing.
Thank you so much. So today, as a part of our CSIR-CGCRI's 1 week 1 lab program, we have organized an industry meet, and we are very happy that there are representatives from different industries who are physically present at this APC Roy seminar hall, and also there are number of industries who are participating online. So in today's program, may I request our director, Dr. Suman Kumari Mishra, Chief guest of this program, Dr. Devashish Bhattacharya, and Dr. Somnath Bandyopadhyay, Chief Scientist, CSIR-CGCRI, kindly come to the dais and take your seat. May I now request our director, Dr. Suman Kumari Mishra, to formally welcome the participants. Ma'am, please.
How many are there?
70.
And here, how many came?
Here around, I think, 15.
Again, very good morning or just good noon, I should say, to all of you. Sri Mrityunjay Das, who was supposed to come, Sanjay Das, Sri MD Webel, somehow due to his he's running with quite high fever and also he could not make it today. And Dr. Devashish Bhattacharya, Bhattacharji rather, he writes JEE. So Dr. Bhattacharji, who has kindly agreed to give the special guest lecture in the very short notice when he came here. I requested him, you have to be also chief guest of that, and I'm very much thankful that he agreed to it. Thank you, Dr. Devarshis, for our this request. I'm very much happy to that Dr. Ranjana Agarwal, she has, as a guest of honor, she has joined online. Again, like morning that she should have been here, but because of her health issues, she could not come today. Dr. Somnath Bandyopadhyay and Dr. Mr. Swaksh Majumdar, both of you who has actually organized this full uh, program of this session of OWOL. Dr. H.S. Maiti, Professor Ranjan Sen, and many dignitaries who are here, all the industry participants, we are very much thankful. I understand about 16, 17s are physically present here and the similar numbers are virtually present for this meeting. I, on the behalf of my lab, as well as on my personal behalf, very deep gratitude to all of you. I can see few from Naroda. I am thankful to you, sir. I see few known face from in online. Thank you very much. And to my all colleagues, very good, good morning and good noon both. It is just was Sandhi Kal mein. So normally Sandhi Kal is a very productive Kal, as we know. So I hope this meet will be industry meet. The session will be very good, and as well as it will be. Always it will be progressing so that industry and CGCRI will be working together in collaboration very well. Before I actually leave this as Dr. Somnath Bandyopadhyay is going to tell you about the technology, but I must tell you that CGCRI is one such lab where besides its fundamental and applied research, it has also made many products thanks to our all mentors and the way CGCRI was incepted, where they have a large variety of works ranging from suppression technologies, biotechnology, not the biotechnology, rather we are into biomaterials and bioimplants, surface engineering, different coatings, high temperature ceramics for different applications, specialty glasses for many strategic applications, laser, high power laser, different sensors such as fiber vibrating sensors and different set of semiconductor sensors this institute works to. Then we are into very much well known in this country for the solid oxide fuel cell work in the energy side, and we have geared for the last 1.5 years for the hydrogen generation and their storage. In this area we are working. I hope industry people who have come, you will have chance to see those research, and we are moving that. Recently we have in terms of fuel cell, where CGCRI had the capability of 1 kilowatt. Already it has developed and demonstrated. Now with HPCL, us and ARCI, we have signed an MOU of a 70 crore project to develop the 10 kilowatt fuel solid oxide fuel cell. This is a recent development. We have a different bioimplants where a lot of technology transfer, about 13 technology transfers are taken, including the last year one. And we have many products which can go, and we are open where what kind of requirements are there, we would like to go. Naturally, remember, we are related to ceramics and ceramic composite. We are essentially and intentionally not touching any metal based things in general. In terms of laser and fiber optics, we have many good successes, which Dr. Somnath Bandyopadhyay is going to tell you. And then we have FBG sensors. One, Dr. Devashis Bhattacharya in the inaugural session, he already said that one success story. But there are many other success stories at the different levels, and they are at different levels of including the railways, such as for the Vande Bharat. Then there is at NTPC and other places. Many tiles and pottery industries are getting lot of technical interventions from us. Specialty glasses, we CGCRI are well known for the strategic glasses and strategic materials development. On them, there are radon development, which is matching with the electromagnetic shielding for many different defense uses, and also that material can be used suitably to the different civil uses too. Similarly, different silicon nitride ball and all, which is normally such processings are, frankly speaking, manufacturing capability in India is not available. That is the one of the drawback we have, because in India it still has not geared towards the very advanced electronics, very advanced materials manufacturing units or the industries are not available here. This is in terms of membrane, we have the technology transfers. In terms of RSL radiation shielding glasses, we have technology transfer, and we are the one where BRC is quite dependent on, not BRC, DAE, I will say, including IG-CAR, where different radiation shielding glasses are being employed, as well as we are developing a newer kind of a glasses which is as per the requirement of those industries. Now those organizations, they are into Department of Atomic Energy. Other thing that we are very good, which can be used for the defense, say chalcogenide glasses for the night IR vision, as well as for the defense, as well as for the IR camera. My intention to tell you that many products are there right now, many startups are coming, people are changing their thoughts with the changing scenario of the government policies, so that newer areas are taking where they were might be working on a conventionally on different area, but they are coming to the newer areas. And these are the things which is required for, if you are talking, to my knowledge, India is going to become the first. um right now they are more focusing towards the strategic area so that they can become more self-sufficient, and that's why quite often this side policies are geared that's by the government. If I remember correctly, 2-3 days back there was a news that Tata Steel first time they made the jet, that was in the news 3-4 days. Jet steel or something you are making, that was, I saw, read in the for the jet, some steel or some coatings, it was there 2-3 days back in the news. This has happened first time, as that Tata has taken along with the abroad industry. So like this, India is now gearing towards the self-sufficiency much more, and government policies are also supporting such things. So CGCRI is one of the lab where many of the labs, when you go, they have processes, they have the products which are very, very at the lab level. Whereas the CGCRI has a niche that where they have a product of a lab level, as well as they have the capability of the product level, and they are very open to grow to from the small to the required level of the productions, and they can handhold with the industry. With this aim, this OWOL industry meet, while we will be discussing, expectations are there, probably my team must have written to you. While we will be interacting, your problems you please let us know. Whosoever industry has come, as well as we are open for the other more industry. And plus you also know us, which you might not be knowing in general. All the areas, maybe some of you are interacting with us and that area only you are knowing, so that our interactions are more. Naturally, I am also a selfish person, a selfish director, a selfish this thing. So I want that my product also goes to the industry. With these few words, thank you very much for joining, particularly to all the industry people who have, in our invitation, you have kindly joined, and we look forward to hear from you. Once again, I welcome all of you in today's meeting. Thank you very much.
May I now request our Director, Dr. Suman Kumari Mishra, to formally welcome Dr. Devashish Bhattacharjee by offering a flower bouquet. Ma'am, please. And I, on behalf of the core committee, I take this privilege to offer a flower bouquet to our director, Dr. Suman Kumari Mistry. And also to Dr. Somnath Bandyopadhyay. Now, the address by our chief guest, Dr. Devashish Bhattacharya. So I read his very brief biodata because his biodata will be very lengthy. So it has been made brief. So he completed BE in Metallurgical Engineering from Jadavpur University, then MTech from IIT Kanpur, and PhD in 1993 from University of Cambridge, UK, with Nehru Cambridge Scholarship. He carried out 2 postdoctoral research assignments, one at Rolls-Royce Technology Centre, Cambridge, and other at University of Birmingham, UK. He joined Tata Steel in the R&D function in 1996 and headed the function as Chief Research and Development and Scientific Services between 2002 and 2009. In 2009, he was seconded to Tata Steel Europe as Group Director Research, Development and Technology for Tata Steel Group based at Netherlands. In 2017, he returned to India of setting up business in materials beyond steel. Dr. Bhattacharya is an expert in development of materials and decarbonization technologies. He has more than 60 international peer-reviewed journal publications, 7 edited books, and 40 patents. Dr. Bhattacharya is a fellow of Indian National Academy of Engineering and of the Indian Institute of Metals. He is a visiting professor at Imperial College London, at the University of Warwick, UK, and at the University of Science and Technology, Beijing, China. Currently, he is Vice President, Technology and R&D, Tata Steel, and based in Kolkata. And Dr. Bhattacharya's hobby includes playing cricket and acting in plays. So with this brief biodata, I request Dr. Bhattacharya to kindly address the audience.
Dr. Suman Mishra, Director of CSIR-CGCRI, Dr. Somnath Bandyopadhyay, Professor Ranjan Sen, Dr. Maiti, esteemed colleagues, may I say, of CGCRI. I consider myself to be a reasonable part of CGCRI. We've done a lot of work together, so very useful work together. Members of CGCRI and members from other industries. Thank you very much for inviting me here, and I'm very opportune that I'm invited to deliver the chief guest lecture at this forum. So it's a privilege, and I also, continuing from the previous session, wish CGCRI a very successful OWOL, right? One week, one lab, and continuing on the theme of OWOL, where the expectation is that the lab will reach out to society and both will learn about each other. Part of the society is industry, part of the society is academia, and I, being from industry, I look forward to the visits and other interactions for the rest of the day. But also it's part of my job, in a way, to talk about what bothers us. And once we have laid down on the table what bothers us, maybe there can be a start of a discussion on what help CGCRI can provide to ameliorate our troubles, right? So here it is. So what bothers us? This is a long list, but I will not bore you with a long list. The biggest thing that bothers us is decarbonization. And it is not just steel industry, decarbonization bothers industry. Some statistics, worldwide man-made CO2 is about 34 gigatons last year, right? What it means is that the CO2 level in the atmosphere has now risen to 450 parts per million. Doesn't sound very big, right? 450 parts per million is not a big number. But considering that this is the highest concentration of CO2 in the last 800,000 years of Earth's history, it's significant. And it's very clear that as CO2 concentrations in the atmosphere goes up, temperatures are rising. And temperatures have risen distinctively since the early 1900s, and rapidly so from 1970s. In fact, from 1970 to 2000, the rate of rise was about 0.18 degrees centigrade per decade. The last 2 decades of the first 2 decades of this century, the rate of rise is 0.36, which is double of the past 20 years. Now, there are skeptics who say Earth has been hot before, so what's new? Right? Is it really going to bother us? Yes, Earth has been much, much hotter before. But there were no humans at that time. At the hottest point of Earth, there were dinosaurs, right? And as the Earth cooled, they died away. So Earth has actually seen 5 mass extinctions, 5 over the last 500 million years. So Earth is quite used to mass extinctions. And every time after a mass extinction, it has come up with new, I wouldn't say, I don't know if it is better, but definitely new and more life forms. After the last mass extinction of 60 million years ago, we saw prevalence of mammals and we had human beings. So the point is that the Earth can take care of itself very well. We need to take care of ourselves. So unless we deal with CO2, unless we deal with the temperature rise, we, as in human beings, are in trouble, not Earth. Earth will come up with some other life form which will be better and bigger and more proliferous than us. Now, 34 gigatons of CO2. The biggest 3 culprits, if you wish, are power, because most of power comes from coal. Transportation, because most of transportation is driven by petroleum. And industry, because a lot of heat, extraction, and other industrial activities happen using electricity and energy which are coal or petroleum driven. Now, the energy industry has, in a way, got a goal for, and as a roadmap for greenification through renewables. The transportation industry has its own roadmap for greenification through battery, through fuel cells, hydrogen, etc. It is the manufacturing industry that is in trouble, including part of transportation, which is airlines. Greenification of airplanes is problematic, but that we'll deal with later. So let's talk about industry. And amongst the industry, it is the industries that extract metals from ores that are in the deepest trouble. Out of the 34 gigatons of man-made CO2, the steel industry in the world, which is the second biggest man-made material, cement being the most, the steel industry gives out about 7% of that 34 gigatons. Now, fast forward 2050, power would have solved its problem, transportation would have solved its problem. If the steel industry doesn't solve its problem, we don't know yet how, but if the steel industry does not solve its problem, it will be 40% of all man-made CO2 that time. Now, 40% of all man-made CO2 from one sector will not be acceptable by society. And we're talking about society today. So the steel industry needs to do something today. to be able to come up with a solution over the next 20-25 years. So decarbonization is the biggest existential problem of the steel industry. And it is multifarious, as I'm going to just describe to you. And in some of these multifarious possible solutions for deep decarbonization, ceramics and materials play a big role. So where does the CO2 come from? In the steel industry, it comes from the reduction of iron ore. You have to take the oxygen out, and conventionally carbon is the best reductant to take the oxygen out, and therefore you get CO2. So the obvious answer is replace carbon. So you can replace carbon by another efficient reductant. The answer is hydrogen. It has to be green hydrogen, of course, otherwise you still have a CO2 footprint. So where do you get green hydrogen from? You get green hydrogen from green electricity, put it in electrolyzers, and then put that hydrogen that's coming out of the electrolyzers into the blast furnace, which is the most conventional iron ore reduction furnace. Now, in the blast furnace, I will not take you through an iron and steel making class 101. There's coal that is used for three purposes. One purpose is heating. Second purpose is reduction. The third purpose is the structural support. It's a tall furnace, and the only thing that is solid at the bottom is coal. Coke, which is a form of coal. It's not to be drunk. It is solid, and it's black, and you don't want to touch it. So everything that's coming from the top becomes liquid, except coke. So no matter what you do inside inside that furnace, that amount of coke has to be there. So eventually, even if you flood the blast furnace with hydrogen, you will need that coke for structural support, and you'll have CO2 outside. So you need to deal with CO2 outside the blast furnace as well, which means you need to do CCU, which is carbon capture and utilization. So carbon, you have to capture to make it concentrated, and there is existing technology using amines. But once you've captured it, you've got 100%, close to 100% CO2. What do you do with it? You either put it down in a well under the ocean or underground. But then you need to have that geographical formation. India in the eastern part doesn't have that geographical formation. So that's not a solution for us. And by the way, eastern India is where most of the iron making is. So the other solution is to put it in or fix that in compounds like calcium carbonate, magnesium carbonate. But there are only so many inorganic compounds you can make and then get commercial value out of. So the solution is to make organic compounds. So you make methanol, ethanol, longer chains of organics, going up to aviation fuel. So it will be sustainable aviation fuel, C8, C9, C10, even C12. And that would save aviation and making it green. However, to make organics from the CO2, you need hydrogen. Again, you need green hydrogen. Now, just to give you a scale of the problem. So these theories are very clear and the solutions exist. So what's the problem? The problem is the world makes about 1.8 billion tons of steel. So that's 1,800 million tons. A typical steel plant, integrated steel plant will be 10 million tons of steel. Rule of thumb, a 10 million ton steel plant will produce 25 million tons of carbon dioxide. So 1 ton of steel makes 2.5 tons of carbon dioxide. So a 10 million ton steel plant makes 25 million tons of carbon dioxide. Now suppose you've dealt with this carbon dioxide somehow, some through hydrogen before, some through other means, existing means. So we have done our calculations for 2030. From one of our plants which makes 10 million tons steel and which will continue to make 10 million tons of steel by 2030. So we will have 25 million tons of CO2 to be solved. We will be left with about 10 million tons of CO2 still, with taking care of all the existing technologies that we can put in. We will not be able to solve 10 million tons of CO2. If that CO2 has to be sequestered into an organic compound, you need hydrogen, green hydrogen. 10 million tons of CO2 will need 2 million tons of green hydrogen to be converted into methanol or ethanol or one of those things. 2 million tons of green hydrogen, what is that? Today, 2023, the world makes 3 million tons of green hydrogen. The whole world makes 3 million tons of green hydrogen. By 2030, just one steel plant will need 2 million tons of green hydrogen to just sequester 10 million tons worth of steel, to make 10 million tons of steel green. The scales are wild, right? So 10 million tons. World makes 1,800 million tons. So you can just work out how much hydrogen is needed. That much hydrogen production, the world today is incapable of. Even if you make that hydrogen, the 2 million tons of hydrogen available through electrolysis, today the cost of that hydrogen through electrolysis is about $6 per kg. 2 million tons, $6, suppose it comes down to $2 by 2030. It will be $4 billion extra cost of steel. $4 billion. And this is just cost of hydrogen. I'm not talking about cost of electrolyzers. I'm not talking about cost of land on which you're going to put the electrolyzers. So, ladies and gentlemen, the problem statement is there's a huge amount of green hydrogen that is required for deep decarbonization, which will partly solve the problem. And this green hydrogen will depend partly on electrolyzers, partly on some sources of green electricity, etc. Electrolyzers today, and of course other routes of making hydrogen, which I'm not going to talk about. So the electrolyzers today are inefficient. The PEMs and the alkaline, whatever you say, are not efficient. They're at best about 50%. Right? Correct me if I'm wrong, but it won't be above 60%. But if you go to solid oxide electrolyzers, with heat available in a steel plant, there's a lot of extra heat available, excess will be thrown away. You could run an electrolyzer at close to 100% efficiency, which would mean you'd have less footprint. For one PEM electrolyzer, you can have, you'll need the same sort of footprint as half a solid oxide electrolyzer. The cost of hydrogen will come down. The land requirement will come down. The $4 billion extra will probably become $2 billion extra. But that's enormous savings on green steels. And I'm sure you can understand where I'm going. Solid oxide electrolyzers is perhaps in the domain of CGCRI. And not only, I know you've worked on SOF, solid oxide fuel cells. Simplistically, just reverse it. It becomes electrolyzer. But there's a huge opportunity going forward to work on materials for solid oxide electrolyzers. And the world is only just waking up. This is like at the bottom of the S curve of technology. There are, as I said, electrolyzers can only produce so much of green hydrogen. I talked about 2 million tons of green hydrogen, and I talked about the cost of it. How much energy do you think would be required to make 2 million tons of green hydrogen? 2 million tons of green hydrogen will need about 15 gigawatts. And that is Delhi, Bombay, Calcutta, Madras put together for just a 10 million ton plant. So there is no way that all of the green hydrogen required for the steel industry is going to be made through electrolysis. You need different ways of producing green hydrogen. Some, such as chemical looping technology, where you have a catalyst which loops, reacts with, I'm not going to go into the details. It does the reactions carries out reactions based on the existing flue gases of a plant, produces hydrogen and also other gases which can be captured. You can think of ways of splitting water or splitting methane using ceramic based catalyst or using ceramics as a base material. The field is open, and any amount of hydrogen that you can produce through non-electrolytic means will be lapped up by the society. So that's a description of roughly what we need, of the problems in the deep decarbonization area. We also have a need to store hydrogen, and that's assuming you've solved the problem of getting hydrogen. So much of hydrogen you need to store, you can't just generate and use. So today, hydrogen can be stored as either liquid hydrogen at minus 230 degrees centigrade, or as liquid ammonia at minus 30 degrees centigrade, 35, or as pressurized hydrogen gas at 700 bar. All of these will need energy. All of these storing mechanisms are expensive, and they are not added to the cost of hydrogen. They are extra to the cost of hydrogen. Now, if you find a material that can store hydrogen easily through either adsorption or absorption through I don't know if ceramics plays a role in that. Pretty sure some ceramic materials would help in storing hydrogen, and that would be a great benefit to society going forward. Moving away from hydrogen, the other problem that we face is the energy transition. Industries guzzle energy, and we need to have green energy to be ourselves green. And we see a lot of potential in not only using our materials in the energy transition, but also to use that material internally to help reducing the load on coal. I'll explain. This is also associated with the word Atmanirbhar. Today, India is dependent on one imported energy material, which is petrol. Tomorrow, with batteries, we will be dependent on a whole set of imported energy materials. Lithium, nickel, cobalt, even high-grade manganese, even the anode carbon materials, they are all today imported, mostly from China. But geopolitically, strategically, it's extremely important that we indigenize these energy materials. An industry like steel, which has raw materials to finished products, has touches a lot of materials in its process. We use a lot of manganese. We therefore have manganese mines. We use a lot of iron in its not so pure form. We don't have to, but there's a lot of scale which we descale, and I'm going to describe it a bit more. So we have access to very pure iron, and I think you can join the dots. The manganese ore can be upgraded to be made into gamma manganese oxide for battery cathodes, and that's an effort. That's a pilot plant now we are working on with CSIR-CGCRI, Karaikudi. We have set up a pilot plant for 5 kg a day production of gamma manganese oxide from our manganese ore. So that, in a way, indigenizes one part of the cathode material for electric vehicle batteries, in LMO batteries. And that's significant. We make coke, and as I said, this coke is not to be drunk, it is not liquid, it is solid. The coal is transformed into coke by heating in absence of air. And in absence of air, a lot of volatiles come out along with coal tar. Coal tar converted to pitch, the low end use is to be used on roads. That pitch can be converted into anode material, and we have converted that into anode material to be used as hard carbon, soft carbon, or needle coke, and eventually not a battery material but a structural material which India doesn't produce, which is carbon fiber. Carbon fiber can come from coal tar pitch coming from coke ovens of steel plants. And all of these pilots we are running simultaneously with many CSIR labs and also labs abroad. So this whole energy transition, so I'm going to talk about the other one also, just in the passing. Have you seen steel coils being transported across? They are usually round, big, and very brown in color. They're brown in color because they have oxide scales. Now, when these steel coils are rolled, subsequently, cold rolled, the scale has to be taken out, otherwise they get embedded, and you would not like it. So the scales are taken off by pickling in acid. But of course, the acid is recycled, so the pickled material, the sediments come out. That sediment is pure iron oxide scale. Reduced with hydrogen, it becomes pure Fe with extremely low alloying elements and absolutely no carbon, which is similar to carbonyl iron, which is all imported to make magnets. The rare earth magnets that we make today, the neodymium magnets, the Fe is imported. And that's because nobody in India makes ultra low carbon Fe for those magnets. But today we are working with NFTDC, Non-Ferrous Technology Development Center in Hyderabad. We have a pilot plant that generates 5 kg per day again of extra pure iron from that scale, and it goes into magnet making, both soft magnets and hard magnets for substituting import. So we are working as a steel company because we touch multiple materials and raw materials and rejects to generate materials for the energy transition and making the country Atmanirbhar. So both cathode materials for electric vehicle battery, anode material for electric vehicle batteries, and magnet materials. Without going too far, the other problem that affects us is competition from other materials. So steel is heavy and corrodes. And you'll see the new Vande Bharat Express is looking so nice. The outside of the Vande Bharat Express is, in the design, it will be, final design, it will be aluminium. And the interior is entirely fiber reinforced polymer composite. Gone is the steel body of railways. So similar is the change happening in automotive. So we are seeing a major change that's happening across multiple sectors, and therefore we need to be ready, and that is why we have interacted also with CGCRI to work on multiple different materials. So we are actually doing business in composite materials. Today we are working on glass fiber composites. Once we get our own carbon fiber, we'll work on carbon fiber composites. And I look forward to work on basalt fiber composites, and that needs high temperatures to make fibers. And I don't think there is a single institute in India which actually actively works on basalt fiber. We have lots of basalt in India, and it's a fiber that's stronger and lighter than carbon fiber. So you can actually make carbon fiber like fiber cheaper and more accessible in India. So that's an area which you may consider looking at. You may still decide not to work on it, but it's an area which has huge potential for the future. We work on graphene and we work on borophene now. And lastly, we work on advanced ceramics. Thanks to Dr. Maidi for our first talk in 2017, I think, when you had given some ideas. I don't think we took forward many of those ideas, but this one we did. And we have interactions with CGCRI on hydroxyapatite. So today we make hydroxyapatite in north of Bombay and we are commercializing it. So we are into medical materials, especially starting from advanced ceramics, and we will probably get into other ceramics for medical applications. Not divulging much, but we can talk about it offline. So the whole field of new materials opens up new opportunities for collaboration between your institute and our company. And just to talk on collaborations, as you can see, we work on areas which are not traditional iron and steel areas. I've not talked about steel products. I've not talked about high strength, high formability steels. Um, but these are of existential importance to us. We need new capability, and we need those new capabilities fast. So we therefore are changing our collaboration model from one-to-one project-based collaboration to institutionalized umbrella collaborations, either co-located or virtual. So we have a MOU with the whole CSIR labs for for collaborations on multiple verticals. We have set up a center at IIT Madras for mobility. We are setting up a center. We have already set up a center on mineral beneficiation at ISM Dhanbad, and two others are coming up. One at NFTDC on energy materials, and one at IIT Hyderabad for construction. And we have just signed two centers abroad, one on advanced materials with the Henry Royce Center for Advanced Materials in Manchester, and one at Imperial College on sustainable materials manufacturing technology. So as you can see, we are not limited to doing all the work ourselves. We can't do all the work ourselves. We have to reach out to where the capability is, and the capability is worldwide, including India. And this is how we keep abreast, and we look for ideas, knowledge, capabilities to react to our needs. And hopefully this dialogue will continue, and we will, because ideas are never frozen in time, they're fluid. And one idea leads to another, then that leads to another, and eventually leads to a project which some of which fructify and become successful, as Dr. Bandyopadhyay did in Tata Steel. So with these words, I would draw my part of industry exposition, if I wish, to CGCRI, bring it to a close, and thank Dr. Mishra for inviting me, and thank you for listening to me.
It was a very fantastic lecture, Dr. Vikas. Few of the areas CSIR is very much, as you have mentioned, coming with me. Regarding hydrogen replacement solid oxide, we are already year 2, and we have getting almost reached what is in research paper has been the target has been placed. Almost we are reaching in terms of the efficiency of one cell, but remember it has to go on multiple cells. He is leading that project along with the NCL, where the NCL, CGCRI and all they are looking on P, and we are into solid. Definitely, you know that we are already in my welcome. I address that time and check that we are developing to 10 kilowatt, and here second one is that your heat energy can it can be stationed. This is can be stationed there, and the heat energy which can give the sustainable energy to the this will give a closed cycle. So that's actually we have the plan already. We are working into that. So that and exploration becomes a closed cycle. So that energy it becomes a less costly process, and it can be implemented. Along with that, we are also developing a newer material in terms of utilizer so that it will become more efficient, right? This is the way if our time permits, we would like to take those limits, and I'm keen to. Dr. Jayanth, can you look at it?
Now, our guest of honor, Dr. Ranjana Agarwal, Director NISPA, due to ill health, she couldn't make it physically, would have loved or to be here physically. But I request Dr. Agarwal to kindly deliver the guest of honor address virtually. Dr. Ranjan Agarwal, please.
Thank you very much. Thank you, dignitaries on the dais. It was really heartening to listen from Dr. Suman about the R&D activities, the whole spectrum. Where at one end they are, serving the industries, high-end industries, whether it is strategic sector, health sector, energy, water, sensors, etc. And on the other hand, they are working on the socio-economic, technology and the capacity building, where they are basically, creating the livelihood for the rural community and the small scale industries. So it's really, really heartening, and I believe that 1 week, 1 lab event is truly serving the purpose to bring out all these activities, to the society and to the industry, different stakeholders, so that they can understand what's going on and they will participate actively into this. My institution is Science, Communication and Policy Research Institute, where we focus on, the science policy. Recently, we were involved in the homegrown technology policy for DSIR, which we have framed. And we also study different kind of, technology transfer and commercialization, and trying to understand what kind of regulatory framework and policy interventions are there. From government side and from how the policy makers make it and how they are executed and how they are really translated, they are transferred and commercialized. Today, if we look at the S&T ecosystem of India, India at 75, it's really huge, very impressive, where we at one hand we have government, central government, science and technology ministry and departments like DST, CSIR, DBT, DRDO, etc. But on the other hand, we also have state and government ministries and councils which are taking up the regional issues. Higher education institutions in India are also playing a very important role when it comes to R&D activities, whether these are IITs or ICERs or central universities and so on. Line ministries which are involved in socio-economic activities like Ministry of Health or Energy, Agriculture. So these are also playing very, very important role. And if we look at the situation today after 75, so it seems to be very impressive, especially when we see a paradigm shift towards innovation-driven growth. And India has created niche in several areas. And one of the major reasons that we could achieve success is that we were early movers in software sector. If you look at the IT industry, that has been, very, very strong from the very beginning, and that made a huge difference. And the success stories we can see in the space today. We all are waiting for the Chandrayaan-3 to be landed on moon tomorrow. Nuclear, we all know. Strategic sector, we know BrahMos and Agni. Agriculture, green revolution, white revolution, and the neem coated urea, and the health sector. India has achieved huge, huge success. And we truly believe that this is because of, the various policy which were in place and the regulatory framework which were there, so that our industries and our society could be benefited by the technologies. If you look at the system, if we talk about the science policy in India per se, the first document came in 1958 after 11 years of independence. That was called policy resolution. So here the main focus was, the inculcation of scientific temper and building scientific institutions or educational institutions. Though we recognize the power of science and technology, but main focus was scientific temper. The 1983 policy talks about the self-reliance, and that was the time, technological competency or development of indigenous technologies were, the importance was realized, and that's why the that policy was mentioned as technology policy statement. 2003, the policy was named as Science and Technology Policy. Basically, this was the first document which was known as policy. And here, science and technology innovation amalgamation was highlighted, and they also addressed the socio-economic needs to be fulfilled through STI. And 2013 technology, science, technology, and the new word innovation got incorporated, and that is STI 2013. So it talks about, not only socio-economic processes, but it talks about the innovation systems, and we can see the results of that STI policy 2013, that today we have Atal Innovation Mission in place, Startup India Action Plan, National Innovation and Startup Policy for Students and Faculty, IPL Policy 2016, and the most recent one, that now the CSIR activities can now contribute towards the research across various fields of companies. So that indicates that how much important R&D activities and science and technology innovation domain are. And they have truly resulted, the outcomes. If you talk about Startup India, Make in India, Smart Cities, Digital India, so all these initiatives which were started by the government, so all these initiatives were basically backed by the policy which was in place. And the government of India also created enabling infrastructure for the innovation, for the startups, for the industry engagement, such as Jam Trinity, the Jan Dhan accounts, mobile numbers, and the Aadhaar cards. They were linked to plug the leakage of the inefficient distribution of subsidies. Similarly, GST, goods and service tax, it has been simplified, a 4-tier system, so that participation of market, a unified common market exists in India, and things are easier to execute. Similarly, 24/7 power for all, that's a very big enabling infrastructure for India. And then the Skill India, where more than 100 million skilled manpower required for 2022 have been targeted, and we are working towards that. So this kind of policy formulation in policy formulations in place, and the regulatory framework, India has achieved this commercialization of technology, which basically involves a complete value chain. For example, in the CSIR we talk about, there are more than 459 technologies which are at TRL 6 and above, and out of that, only 20% technologies have been commercialized. Rest of the technologies have a huge potential to escalate the TRL level or to enter into the market with partnership with the industry, but they are not, has been transferred or has not been commercialized. So that means we need a concerted push towards this, that how the TRLs can be escalated, and to understand the whole value chain of research, innovation, and commercialization. Presently, we take, as we do things in silos. Research organizations work differently, academic institutions separately, and industry separately. We develop the technology, but we involve the industry at a much later stage without knowing or without understanding the demand of the industry. So that's why there is a big, hurdle in transferring the technology to the industry. But there is a very good example which we all know about the co-vaccine. When the COVID came, not only globally, even within the country, people kind of ridiculed that how we are thinking of developing a vaccine within a short time, and then promising that it will be given to the whole population of India and also for the countries who does not have this kind of capacity to build their own vaccine for COVID. So it's a very beautiful example where research, innovation, and commercialization came together, and the technology and the research which was already existing in our laboratories. It was not the new research which came out at the time of COVID, but how the research, innovation, commercialization, the whole value chain was created. So it was basically Bharat Biotech. We all know that Bharat Biotech produced the Covaxin, but there were so many other players in the whole success stories which played important role, and they all came together. For example, Indian Council of Medical Research, National Institute of Virology, they were all together. And then our scaling up manufacturing unit was also, scaled up, like Ankleshwar plant from GSK Asia, they manufactured Covaxin. Similarly, Indian Immunological Limited, Hyderabad, they manufactured and supplied the Covaxin drug substance. CSIR also played a very important role in the development of Covaxin, the adjuvant which was needed, that was produced at IICT Hyderabad. And then 3 public sector enterprises like Hafkin, Bharat Immunological, Biologicals, Limited, Bulandshahr, they all came together and supported the government for scaling up. So the research was there, scaling up was done, and then the technology was transferred through the intervention of DBT, Department of Biotechnology. They transferred the Covaxin to 3 institutions, Omni BRX and Ocugen, which were responsible for US, Canada, and other countries. So, a beautiful example, when there was need, we all came together and created the value chain, and the technology could be transferred. So I think it's a very good lesson. The whole study has been done at our institute. So it's a very beautiful lesson which we have learned, that how our technologies which we are developing individually can be, working together. We can do that, that they see the light of the day. As there is scarcity of time, so I will just like to, talk about few suggestions or the way forward, that how should we go about when we are talking to industry. We should introspect why our technologies are not making that impact which they should. Because indigenous technologies are low cost, they are affordable, they have the efficiency, they are sustainable, but somehow we transfer the technologies to 3-4 licenses, and then we do not see this, complete impact. So it's very important that whenever we are in the technology transfer operationalization is taking place, before that, we develop the technology in public-private partnership mode. Industry should be invited, in the initial phase when the technology is at TRL level 1, 2, or 3. At that time, industry should be involved in the development of the technologies. Similarly, we are talking about triple helix model, where academia, research organization, industry, and government, they all should come together and create a triple helix model for the development of technologies, so the transfer will occur automatically. We should also consider open innovations, where we share our competencies among the stakeholders, and this learning can definitely escalate our TRL levels expeditedly. And this is also the time when OECD countries are moving towards, quadruple helix from triple helix. So they are also involving society and public participation, where the innovation processes are being taken up. So they should also be included. Industry should also be encouraged to adapt indigenous technologies, because many a times they have their R&D centers, and DSIR also give tax incentives to them. But it seems easy and more economic to go for the foreign technologies, but indigenous technologies which are being developed within India, they should be promoted by giving incentives and awards. For example, subsidy in the initial phase, so that if the risk is involved, that can be taken care of. Regulatory costs are very high, particularly for the small and medium scale industries. They do not have that much of funds to invest in R&D, and the regulatory costs are too high for them to adopt indigenous technologies. So how we can reduce the administrative charges, and how we can cut down the cost of SMEs, so that should be kept in the focus. Another important parameter, that our advisory boards should have the private participation of private sectors and innovation participants, because they understand the problem of MSMEs or the industries at the ground level. So when they come with us with their knowledge, and working with us, we can also help them to getting their IPR rights protected. So that kind of arrangements having in the advisory bodies can be very useful. And another most important thing which we forget about, the communication part. In science communication, we generally see, first of all, we do it only in English language most of the time, and only 20% of our population can understand English. The regional languages we do not cover up. Our industry partners, those who can be small scale or micro industries, they may not have that exposure to the technologies, but we are developing in our labs. So I believe that the popularization of potential technologies must be done in a very, very big way on social media and other electronic media or the print media, not only in English but also in vernacular languages. And we should have small these kind of interaction sessions with the industries. We should do the outreach programs where we can basically inform the society, inform our stakeholders about the technologies which are available with us. And I think these kind of initiatives, strategies will definitely help us to transfer our technologies from lab to land. Industry will come forward, and I'm sure that the kind of work CGCRI is doing, which is very, very relevant for the industries and for the society, they can definitely provide solutions for Atmanirbhar Bharat. Thank you very much. Once again, I congratulate Director CGCRI and Team CSII for organizing the beautiful event, and I wish them a huge success for the whole week, 1 week, 1 lab. Thank you so very much.
Talk and
Thank you. Thank you.
we are and particularly in communication, you are the main source to that. Thank you so much.
Thank you, Suman. Thank you so much. Namaskar.
Now the address of chief guest and the guest of honor lecture is over, and since Dr. Bhattacharya is physically present, I request our director, Dr. Suman Kaur Mr. to kindly felicitate Dr. Bhattacharya with a shawl and a memento as a token of our appreciation. Thank you, ma'am. Now there is a slight, yeah. We thought of introducing CGCRI's activity first and then straight away go for industry interactions along with the introduction part. So now Dr. Somnath Bandyopadhyay, Chief Scientist and Head Fiber Optics and Photonics Division, he will give the overview of the CGCRI activities. I request Dr. Bandyopadhyay to kindly present that.
Good afternoon. Yeah, let me start. Good afternoon, everybody. Dr. Bhattacharya, Dr. Bhattacharya, the same, our Dr. Maiti, our director, all the dignitaries. Yes, it is my responsibility today to give you an overview of about CGCRI. And already since morning we have been discussing that the various functionalities and contributions CGCRI is having. The CSIR lab, CGCRI's position and the credibility is really enormous. But my duty is just to give you some documents. Specifically, I know that this is not the first industry meet. We do it regularly, and most of our industry, I mean friends from industry, those who are connected virtually and are present here, they regularly have interactions with the close groups and their field of interest. But now, during this function over this week, we are having one opportunity to get them and get their presence all together and give them a very clear idea that what we are doing. But mostly this is more important for the people, friends who are connected virtually, because the industry people, those who are here, they will have enough opportunity to visit our labs, to interact with our scientists directly one to one during this. So yes, we before going into this again, I must say that yes, CGCRI, since it had started its journey, I will just quickly go through, and the discussions that we had since morning, that very important thing for any institute like governmental research institute, as Jana Agarwal has very clearly mentioned, that how to transfer or translate the R&Ds that we generally do to the industry people. But yes, COVID has given us a very good lesson. But I must say that we only survived during this COVID because we had a very rich background knowledge on this field of area. So one day we couldn't have got that. So similarly, whatever we are doing now in CGCRI, yes, I mean, because of various policies, I mean, presently government has taken more and more exposition to these R&D institutes, with the institutes are coming, becoming very important. But it is not a magic that everybody will come to a CGCRI scientist and will ask for a solution immediately within 6 months or so that can be given. So it is true that since 1950, from our inception, we had a very rich knowledge. We have built out our portfolio on specialty glasses, ceramics, and the other say branches which have been developed on our basic activities and research freedom in the glass and ceramic research area. So I will just closely go through. We always feel proud because we should see, for our junior members, we always teach that we should start our journey, and we should know that where from we are. And this is a very important slide that always encourages us that we had started the foundation stone was laid in the year 1945, and then ceremoniously it was inaugurated by none other than the chief minister at that time, Dr. P.C. Roy, and already it has been discussed that the stalwarts from Cultivation of Science, C.V. Raman is there, Dr. Bhatnagar is there. So these are really a proud moment, and when we think that how the CGCRI has come up, it gives us a lot of encouragement. Now, some early achievements from the very beginning. Our founder director, Dr. Atmaram, he had a notion and he set right the tune that yes, fundamental research should always be there. But you have a very clear and focused idea that whatever you do, that should be taken to the common people or to the stakeholders, so that the research that you are doing is to some extent, you may say, is meaningful and usable to this community. So we can see that in 1950s and 1960s there were very clearly developed products, and can we think that the porcelain spark plugs at that time in 1950s CGCRI has developed with the indigenous development of the material as well as a product. And then there were a lot of other specialty glass and ceramic product, which we can see that one of them is optical glass, and also a special IR transmitting glass. Still we are working with this IR transmitting glass, chalcogenite glasses here, but it was started in the 1960s, and the foundation stone was laid in this way. So we are still continuing and we are improving these technologies, we are taking these things to the market. Now, as of now, if we see, as we have discussed, each and every field that the photographs which we have given, it is not merely we have taken it from the internet. CGCRI's presence is everywhere, everywhere. You just simply name one area and just ask one of our scientists that where CGCRI is connected in these fields. There are at least 2-3 applications, and starting from the material development to the product development, CGCRI's presence is there. So let us see that where we are actually fitting and where we are at present in these areas. So the key domains of work we must know. We have started our journey based on our richness in the glass and ceramics. So still today, optical glass science and technology is the backbone of CGCRI. So the works that we had done initially when these researches were going on, there were certain phases. You may see that we had again when started all these things. There were a few guarded technologies. CGCRI mostly was given the responsibility to develop a very special type of glasses and ceramics, which was required specifically for the strategic sectors, because these things were not available in open market. And CGCRI, relentlessly put their efforts to develop these products. And some of the examples of these successful stories are development of the radiation shielding windows used in nuclear power plant, as well as borosilicate glass beads and glass beads for nuclear waste immobilization. These are the certain examples. Let us move forward. Then came the laser mission. High power laser and the high power glass laser is a very important mission that Government of India, apart from all these digital India and other things, laser mission was considered to be very important at one point of time, where the requirement of the specialty glass was absolutely not available. Absolutely required for high power laser development, but it was not available in the market by those like RR Cats and all those people, those who make high power laser. So again, the responsibility came to CGCRI team. CGCRI team had developed neodymium doped glass for lasers, high power lasers. CGCRI has already also developed cage clad glass for the laser disc, and most importantly, immediately developing these technologies and handing all these technologies to an industry is not an easy job. So initially, all these funding agencies or the government agencies, those who are dealing with the development of these high power lasers, they bestowed on CGCRI's capability and asked us to come out with a pilot plant so that the initial set and initial batches of all these products can be delivered as a commercial product for the development of these. So that was a hilarious activity, and presently developing these 15 liter and 5 liter capability for this laser glass is also commendable. I mean, the friends, those who are here, you can see all those facilities. Similarly came the requirement from this space research. It was funded by BSSC ISR that to develop 5 to 6 very specific optical glasses. They are unable to import, and they do not want to because of this cost, and the tailor-made things what they generally need was not made available. So the responsibility was given, and it was a very big and prestigious project. I think I remember it was costing around 19 to 20 crores rupees for creating a full facility of developing space grade optical glass at CGCRI, and that is successfully working, and we have been successfully developing those glasses, and these are the facilities. So these are the things where now when the all these things come up to a certain level because we had a very rich background or background knowledge on glasses. So at this moment what we are able to see that Dr. Ranjana Agarwal has mentioned that now people are looking the system towards a top-down model, because we are also facing that people from industry, they are coming to us and asking for some solutions, that we need this solution. Are you ready to provide this solution? So it needs confidence build up. If we say that yes, we would be able to do that, but developing a technology and transferring this technology so far as the acceptance is concerned needs a certain gap, and it is not less than 3 to 4 years, I must say, from the day we developed it, from the day we field trialed it, and then acceptability. Just that example which we had with Tata Steel, still it is running. What he had mentioned that for the last 2 years it is running, and that is the confidence build up. Yes, now it is in a position where we can transfer this technology to a certain organization, and the steel plants will start using this thing. Similarly, whatever we had done with the other companies, so this confidence building is also, we have seen, is very, very important. And during the past quite a few years, when we were completely concentrating on developing strategic products, we missed the bus slightly because we didn't have all the facilities to cater to the industry people, those who sometimes wish to get a very quick solutions. But now things are gradually moving to a different direction, and we see that the other areas where CGCRI has already developed quite a few important technologies. It has already been discussed. This is the non-oxide ceramics, where high temperature applications of these ceramic materials are used. CGCRI is one of the pioneers. And again, coming back to this development of radome, which is a very important strategic applications. Generally it is used in the missiles, and CGCRI's responsibility is developing these things. This green energy effort, what we are now working with, already has been discussed by Dr. Bhattacharya. Yes, CGCRI is now having a very strong positions. Whoever is interested to go into the details of all these things, they can directly contact to our energy division, that is Dr. Jayantu Mukhopadhyay, and we'll get all the details that what we are doing in this green energy. Also in the development of indigenous anode supported solid oxide fuel cell has already been discussed, and this is again a very big project which our director ma'am has clearly mentioned. It is a consortium project where OIDB and the CHT, they are having a consortium and a partnership with CGCRI, where the technology will be developed by CGCRI. Now in CSIR's hydrogen mission, CGCRI is again playing a very important role. Specifically here we are concentrating on the development of electrolyzer technologies. Then Dr. Bhattacharya mentioned that there is another important thing when you deal with hydrogen, that is how you store safely the hydrogen. Here our sensor department along with CMARI, those who are developing the tanks and the bottles. We are collaborating with them. And also this high entropy alloys for hydrogen storage application operable at room temperature, that also is being a part of the responsibility of CGCRI. So it seems and it appears that whatever the discussions initially we are having since morning, I mean, I'm just replicating all these things with certain documents to give you confidence that yes, these things are now available. I know it is nothing new to many of the people, those who are directly having contact with individual groups. But again, I'm saying, as we have got a very good opportunity to bring all these people under one umbrella during this function and during this week. So we are now just giving all of our portfolios. So you see, developing, I mean, ceramic materials and glass material is very important, and that we always discuss that it is the responsibility always for CGCRI. You see that the same ceramic material, when it is used or developed specifically for biomedical and healthcare application, I mean, basic material is ceramic, but you see that in healthcare applications separately CGCRI has come out with a lot of important solutions, and I'm again giving a glimpse that they are working in specifically the load bearing, I mean the products which are categorized under this load bearing products and non-load bearing, and each and every component that you see is requiring or requires a very important and specific material, and then transforming this material to a specific product. So here at this point, the knowledge base that we have developed, this is one example. The knowledge base which we have developed, gradually it is being converted into a foolproof and field proven technologies, and the industry people, they are now coming on to us and trying to find this solution and getting themselves satisfied is also a very important task for us. Now let us move around to some other aspects where we have dedicated departments or divisions, those who deal with functional materials, and all these special materials are being used directly for product development. Just I am giving one or two examples which have been very successfully installed in one of the NTPC plants, that is the humidity sensors for oil moisture and measurement in transformer oil, as well as the humidity sensors in air. And very recently we have been given a responsibility from NIOT Chennai to develop these moisture sensors for IMD. I mean, all these moisture sensors are known to everybody, but IMD till today imports I think more than 1,000 sensors in one quarter, and all are imported, and very few people are there in India, those who develop this moisture sensor. So we are now taking these opportunities with our background knowledges. And in rural industrialization, we have already discussed, I am not going into this. Dr. Maiti has already mentioned that starting from a very high-tech solutions that CGCRI is catering for, we come down to the grassroots level of people, those who are getting benefited. There are special days and special events already planned during the next few days, so I am not going into the detail. Our Purja and Naroda Center will be describing all these things in next few days. Ceramic membrane, already Dr. Bhattacharya has mentioned. We are again working with the grassroots people, developing filter plants for arsenic, for iron, and giving them pure water. There are many industry people I know, they are already here, and they are using these technologies, deploying these systems in rural sectors. Now, technologies developed using specialty silica optical fiber. You see that starting from specialty glass, then we came over to ceramics, and now optical fiber is a glass product, glass-based product. But here, the development of optical fiber is specifically done for making few very high-end components, where I mean specifically to mention that nowadays optical fiber lasers optical fiber sensors and optical fiber amplifiers, they need a very special type of fiber. Again, those fibers are very costly. Tailor-made availability of the tailor-made fiber for use in all those applications are rarely available, and that's why unless and until we have our raw material, that is we have our own fiber, developing all these products wouldn't have been possible for us. So let us see that in the lasers we have successfully built HFEM doped fiber laser lasing at 1 micron, and these fiber lasers, I must say that there are quite a few friends, they have been connected, they are already joined virtually, and we are now directly working with industry people. This 1 micron laser, it can go, I mean, it has a different application starting from few tens of watts to hundreds of kilowatts. I mean, at that highest power level, it is having only the strategic applications for weaponry. DRDO is looking for all those things, and I must say that one company is already joined. We can have feedback from them. 2 kilowatts and 3 kilowatts lasers with all the imported components has already been built by an Indian company, and those have been trialed, those have been tested by DRDO, and now the question is, I mean, it is, the decision has been taken that once that has been built, now it is our responsibility to replace all those imported components with the indigenously developed fibers and other components. So that is what CGCRI is doing, starting from the fiber for high power lasers, combiners, and fiber Bragg rating, which needs to develop these lasers. So these lasers are generally used for additive manufacturing and laser based machining. Everywhere these types of lasers are used, and all are imported. Now let us see that if we just switch over and use the same technology of laser development, just change the material of the fiber, we can have a laser at a different wavelength, like say 2 micron wavelength, where that particular laser is developed for urology, and it is going to completely replace holmium YEG laser, which is now a gold standard for surgical applications. So this particular laser's prototype has already been developed, and now these lasers have been, I mean, what I must say that the industry people, they are from the very beginning handholding with us, and with the background knowledge that we have developed, they are taking all these background knowledge and developing this system. So the system that you are seeing, this thing, it is fully developed by an industry people, where minimum contribution is there from the CGCRI, apart from the basic knowledge which is given to them. So we have all these developed characterization facilities. We have pulse fiber lasers for machining, engraving. So at this moment, with all this portfolio, whenever the industry people, they work with us or they come to us, they immediately get quite a few solutions, immediate readily available solutions, and take these products for making systems for them. Now, this is a very clear picture, I mean, based on which we are getting confidence. We had just about 2 months back, we had a good consortium and an industrial meet specifically with the people, those who are developing systems, means metal cutting systems, metal machining systems, additive manufacturing systems in India, but all of them, they are importing high power lasers of different category. So some of them, they had a very clear perspective, and they had calculated that if we now invest on developing this high power laser complete say ecosystem in India, then if we invest X amount, that how quickly we can get the ROI back to this. So a very clear idea they had given that by 25-26 there will be a requirement of around 1200 to 1300 high power lasers in India for making systems. A very clear picture. Market is there, and the most important thing is that they are making machines. All the robotics, all the programming, software, everything is developed by Indian companies. But the pain point is that they have to import the laser, and again they are banking on Chinese quality assurance and all these things. So they are insisting on us that if we simply are able to develop completely indigenous laser in India and stop the Chinese influx. 150 crores per year business is there in India. A very clear picture. And now gradually if we migrate ourselves that we start exporting these lasers of different category to the European market, then export sale can grow up to 300 crores, and it is just only 2% of the global market if we are able to get. So now that the things are gradually changing, and as Dr. Maite in the morning just with personal discussion told that gradually we are also getting focused, and without the industry participation and feedback from industry, these things wouldn't have happened. I mean, this is very important. In each and every aspects we see that these things are coming in a big way. I will not waste time giving you a very detailed idea about what we are doing in optical fiber sensors. Optical fiber again, what we are doing, it is a very simple sensor. Why these sensors are coming in a big way? I mean, I can see there are 2-3 group of organizations, those who are directly working with us in sensor area. Their requirement, and in many forums we have heard and we used to get this feedback from them, that we are getting a lot of health monitoring projects from Indian Railways, say from transformers health monitoring, generators health monitoring, but we are solving those problems, but we have to buy all those components, we have to import all those components. So can't it be possible to replace at least part of the system? First point, the important thing is the sensors what we are now working with, it is using optical fiber. The advantage I have just given 2-3 advantage because it has a very niche area but a very important area where electrical sensors, it is all pervasive. We can see electrical sensors starting from our washing machine to everywhere where we generally use sensors. But there are places where electrical sensors cannot even work, cannot even function. So here, this optical fiber sensors we are targeting because these are absolutely electromagnetic interference free. It can be multiplexed. And now just see how we have been migrated at CGCRI. The center that we are, just a moment, the center that we have been given the responsibility to make is to build up a center, to build up an ecosystem. Means it is not that CGCRI will only do some research on fiber optic sensors and showcase few products. It is the responsibility of Government of India given to CGCRI that whatever you have done for the last 10 years in sensor, you have to create an ecosystem. You have to build up the self-reliance by making sensors. Then you have to take the responsibility of capacity building. That is also very important because immediately developing sensors and giving these to industry people, it is very difficult for them to take it over and do all these things. And finally also you target to have business incubation and innovations to industry. Now I will just give you certain examples where CGCRI has solved certain exciting problem. This is an example of an instrumented pantograph where optical fiber sensors have been deployed in, briefly I'm telling, deployed in a pantograph. So when the loco is moving, they are getting 4 valuable signatures, that is the contact force between the wear and the pantograph, contact location, stagger of the wear and height of the wear. These 4 parameters still today Indian Railways measure manually by stopping a tower wagon and then manually measuring all those 4 parameters. Optical fiber sensors, it is working here at 25 kilovolt. None of the electrical sensors can work at this place. So these are the advantages. One example I have given to you. Similarly, this is another example where we had put generators. So these generators, when they operate in closed form, it runs in around 2 to 3 Tesla magnetic field. NTPC wanted to measure the vibration of this stator end winding within the generator. And none of the electrical sensors can work. So here we had put the fiber optic sensors, and again I am talking about the confidence building. These sensors are working in those generators for last 2.5 years, in 3 of the NTPC generators, and they are all production generators. So they are now giving certifications that yes, these technologies can be adopted by NTPC and the power sectors, and we are very soon we are going to transfer this technology. So now, after discussing all these things, I may have taken slightly more time, but we see that CSIR-CGCRI, with all this technology background, we are contributing everywhere in almost all of the missions that has been announced and that has been floated by Government of India. And similarly, the snapshot of the collaborators, we are having quite a good number of and rich portfolio of collaborators working with us. We are having a lot of international collaborations, and some key institutional metrics for any institute is also very important. Most importantly, we are now around 280 people out of those 85 scientists are there. And with this, let us just hope that we will have a very close interaction with the industry people, those who are present here, and we will have visits in our lab. And the people, those who have already joined online, they can now discuss openly. And I mean, we are open in any point of time if they want to have any solutions. Right now, I do not know, Dr. Bhattacharya in the dais just asked me that you develop strain sensor. Okay, I will put somebody to come to you. So the things move in this way. I mean, once we see that there are confidence, there are things coming up in reality, so the things are getting more and more attractive to these industry people. And hopefully this will give us a good journey forward. Thank you very much for your patience and listening to me.
Thank you, Dr. Bandyopadhyay. Now, since time is short, we'll go for introduction come open discussion session by the industry participants. So first we'll start with our online participants, industry. Dr. Narayanan from HPCL Green Energy Center. He's not there. So I request other online participants kindly introduce very briefly and then say very few words pertaining to this industry meet program relevant to CSIR, CGCR and your activities. Online participants, please. Anybody? Please raise hand and unmute. Yeah.
Hello.
Yeah, we can hear you, sir.
Okay, my name is Rupesh Shah. I am from Ahmedabad. Name of my company is Sonia Ceramics. And I am really glad and I must congratulate your entire team for conducting such a lovely program. I was really fascinated by the lecture of Devashish Bhattacharya, Somnath Bandyopadhyay, and of course our director Sumitra Mishraji. Congratulations to all of you. We have been associated with CGCRI since its foundation, and we are very closely, having it. I'm already into the advisory committee right from beginning, and my father, Chandrakant C. Shah, was the founder member of CGCRI Ahmedabad unit. And I'm glad that what CGCRI Ahmedabad is doing is a very nice interaction with the industries. Talking about myself, right from when we were making salt glaze stoneware pipes, the salt glaze was not accepted by the GPCB, Gujarat Pollution Control Board, and we had made a very good representation with the Government of India and ISO committee through CGCRI, and it was very effective. Later on, at the time of Mr. Maiti, who was here, he helped in developing cups and saucers, especially crockery industries. And at that time, I was president of All India Ahmedabad Pottery Manufacturers Association. And the development of sagars was also done very nicely, as well as development of better quality of crockery was also done very nicely. As my company is, as far as it is connected, I appreciate we had done energy audit for our furnaces through CGCRI in the past, and we continuously are in touch with Ahmedabad unit. And for the first time, this 1 week, 1 lab program is conducted. I really appreciate the approach of CGCRI and CSIR to be in touch with the industries. I hope things will be more and more interactive in the future.
Thank you, sir. Thank you for your valuable comments. Anybody else online participants? Yeah, Dr. Sudhakar Reddy.
Good afternoon, everyone. Let me introduce myself. I am Sudhakar Reddy. I'm a R&D head from Stellar Technologies Limited. We manufacture optical fibers and optical fiber cables, and which is one of the biggest portfolio from CGCRI. For example, they are working a lot in this portfolio. And the good part is that we are already working with CGCRI in not in a big way, but in a small way. For example, we are already working with the Dr. Annapurna Group, for example, on converting one of our byproduct SiO2 to some useful quartz-based materials, those kind of things. Yeah. And to come, just coming back to the this meeting, it's really great to hear that the government labs have a decades of experience and a vast wealth of ideas and technologies. Getting interacted with the industry is one of the biggest, I can say, requirement currently for the country and for the private industries. And definitely we look forward and working close with the CGCRI, and very sure that our collaboration will definitely yield results and products which are beneficial for society, and for private industry, and for the government also. Yeah, thank you.
Thank you, sir. Anybody else online?
Yes. Hello. Yes.
Yes, sir. Yes, sir.
I am Gigi Trivedi, Chairman, Vidres India Private Limited, Ahmedabad, and ex-CEO of Somani Ceramics Limited. I would like to say about the contribution made by the CGCRI to the society rather than to an industry. Because in the development, as Rupesh Bhai has told, in the development of crockery industry, CGCRI has played role. Plus CGCRI and Naroda Center has played role in the development of Morbi ceramic cluster. Today Morbi is on the world map, but at the root of the development is the CGCRI, because they have spent a lot of resources, energy, and senior technicians have spent a lot of time in development of ceramic tile industry at Morbi. So cluster development at a national level is a major role played by the CGCRI in Naroda. Thank you very much.
Thank you, sir. So if nobody else is there on online mode, we'll move to physically who are present in this seminar hall. So I think some of you have already introduced, but possibly I will request of the first Datta sir, if you can introduce and say very few words in very brief, because time is very short.
Hello, thank you all. Actually, I'm from retired engineering, public engineering, and now principal consultant of NAPCO. During my tenure, we are facing a lot of problems of arsenic and other environmental pollution. And CGCRI helped us a lot during arsenic elimination plants and pre-treatment units of the. One thing I just request them, this field is totally remain unexplored. that is the cleaning the natural resource, natural water bodies by using ceramic and other materials. During my stay in Kochi University, Japan, I find that they use total river Sumatra has been cleaned by using different material like zeolite, cytosol, or like that under plateau condition. So I request the CGSC activities. We all facing this environmental pollution of the natural water bodies mainly due to the presence of excess nitrogen, phosphorus. If they come with the research, it will help the total mankind. Thank you. Thank you all.
Thank you, sir.
Hello everyone, I'm Naveen Gupta. I'm the co-founder at Arusha Water. So we at Arusha Water, we are working towards providing safe drinking water to small communities, especially in remote areas. So during the last 4 or 5 years, we have been including a lot of new technologies in drinking water sector, and we have been trying to solve problems, especially in the remote areas where they don't have access to drinking water. And mainly because they don't have access to technology, sometimes they don't have access to power or any other thing. So there are various kind of things that stop them from getting this access to safe drinking water. So it was only last year that we started using ceramic membranes as a technology process in our system. So we do this through our water stations. We also call them water ATMs, and it gave wonderful results. So apart from low maintenance and long life, it saved us a lot of time and maintenance costs. And in remote areas, it becomes very difficult for technicians to go every time and manage these kind of machines. But these are so reliable technology that it actually made me think like, why don't we collaborate and we come with more new solutions that can solve these real social issues. So actually, ceramic is magic. And, we want this magic to solve some of the most pressing social problems in drinking water and sanitation.
Next. Here.
Good afternoon. I'm Dr. Vishwajit Research from Healthcare Industry. Hospital and lot of work in the field of microvascular surgery. New innovation is related to the implant dentistry and cerebral parts since long. Our request towards this but if this dental technology is a wonderful area, it's millions of dollars can be invested in this particular area. And with ceramics, zirconium, the new materials, they're working up together and giving wonderful result. So if this can be converted to Indian focus, thanks.
Thank you, sir. Next. You want to speak some? Oh, it's okay. Here. Next. Here. এদিকে তাকাও চলে যাচ্ছে
I'm Nitin Banerjee. Actually, I'm working in Georgia India for years. Georgia India working in the field of water treatment last 3 years. And we are using CSIR technology last 6 years. We have done a lot of job in Bihar, but other states like Odisha, Jharkhand, West Bengal, Northeast India. Because I think we probably not recently not done this type of scheme. So I think in future I can be able to this job. Yes, thank you.
Thank you.
Very good afternoon, everyone. I belong to, I work as a engineer at CSIR Private Limited. So We are a company which deals with the real-time condition monitoring of high voltage electrical assets. We provide that as a solution and service, and we have been doing that for almost 10 years. But recently, we have seen the problem that major industries face. Solution, the condition monitoring solutions are mostly all imported solutions. So we have taken this step ahead, and we have introduced developing the solutions under the Atmanirbhar Bharat Abhiyan. We have taken a step forward by developing the solutions indigenously in Made in India initiative. So we have successfully developed and already commercialized UHF sensors for transfer partial discharge monitoring. The technology has already been adopted in Nepal and other major utilities in the country. And apart from that, we have also developed epoxy mica coupling capacitors for generator stator winding insulation monitoring. And partial discharge detection maybe. So that's what we are working on, and we CSIR-CGCRI for winding hotspot fiber optic development. We are also working on motion monitoring technology developments also. Thank you so much.
Next, sir. Here. Please, Mahendra.
Mahendra, working at High-Level Corporation R&D Center. We are looking for CSIR help for developing the ceramic membrane to redefine the work, so we can have a circular economy and have a greater technology and greater business together, so we can have. We are looking for help of CSIR.
Thank you, Mahendra.
Good everyone. Thanks for inviting. I'm Dr. Siddharth. I'm representing Climate Service Solution. Actually, we are a consulting, engineering, and product development enterprise. We have laboratories across the world. India is based in Siliguri. I'm basically an agri scientist and research scientist. Climate Service Solution is basically our main focus on three areas: water and shelter. So we are basically addressing to address the challenges that we humans are going to face, and we are actually facing, as we are seeing unprecedented changes because of the climate change. There is sharp contrast. We have drought in one end, and then we have flood. We have recently seen in northern India how the floods have. It's a challenge because it doesn't only affect the water and the shelter, it also affects the food. Across the country, we have seen price of fruit vegetables. So humanity is actually, we are living in condition instead of survival mode. So and in future, not in future, but now we need to address our basic, basic survival things which I mentioned as food, water, and shelter. So my company actually is working on how we are going to treat wastewater as a rich resource, not something which is to be dumped in the drains. So we are building a qualifier system, which is our, the patent is in progress. So this is basically, we believe that centralized or as we say, the STP treatment, wastewater treatment plants are not going to solve the crisis, because by 2050, only, if you have two, then only one. So half of the world's population is not having access to the clean water. So in that, in that situation, we must deal with wastewater as a rich source of nutrients, because as we have seen the political disturbances of Russia and Ukraine, we all know the price in the fertilizers, and that is for food. We need fertilizers. Wastewater is a very rich resource of not just water, which is 99%, but also the resources that we need, the the nutrients that is required for food production. So we were looking at treating. We have actually a demonstration facility in our Mexico site, and we on the our flagship project is under the is underway in Arizona, USA, because Arizona has specifically been chosen because it's a desert and water scarcity and drought is a major problem. So we are, we want to address the real situation, real problems that we are going to tackle, and we are, we don't have, or not everyone has the access to the clean water. So with respect to CGCRI collaboration, our we are building actually a climate resilient or climate proof self-sustainable habitat and community resource center at Arizona. The construction is also already built. And as Dr. Debashish Bhattacharya, he has mentioned that our major challenge is decarbonization. So in every sector of the economy, we need that decarbonization. So in our habitat, which we have called Technique, everything will be made using, we are not actually relying on cement-based construction materials. We are an architect there. He's utilizing the local soil at the construction site. So for CGCRI, we need their help to, to come up with something that could replace the piping material, the PVC. It is inexpensive, but it's not economic friendly, and also it has so many disadvantages, and not also it's a possible waste. So we want their help to build replacement for PVC pipings and conduits, or electrical conduits also. So that we, so we are preparing a model there in Arizona, but in future we are going to make such models of climate resilient habitats all over India, all over the country. Like we in Mexico is there, and in Siliguri, I'm actually looking at how we are going to develop non-conventional food sources, because like in climate change conditions, flood and drought and mega fires, our food is also at the risk. So we need to look for unconventional food sources. So I'm working, and we are actually in a phase that we are selling aquatic plants like duckweeds, which are actually which have multi-usage. We are using that for treating the wastewater, as well as putting it as an option for unconventional food source, because it's rich source of protein both for humans and for animals. So thank you so much.
Thank you. I think Dr. Narayanan is there from HPCL R&D Center, GM R&D. So, sir, can you say a few words?
Yes, sir. I think, it was a fantastic session. I've been waiting for the morning, but I have no regrets. Despite of getting late, I could hear a lot of things, and I think I can't agree more with Dr. Bhattacharya of TISCO. I think all of us are in a crossroads. We are trying to, do the energy transition, decarbonization. I think the issues and the challenges which Dr. Bhattacharya highlighted, I think are valid even for the companies like HPCL. It's like, the biggest challenge is, is that we know what to do. We have to decarbonize is known, but how to achieve that, or how to do the energy transition, it's not an easy task. I think more than, I think we can say that, 80-90% of the technologies which are really commercially viable technologies which are required for the energy transition is still not available. We know we have some small shoots, but I think we need big trees and forest to sort of do this energy transition. I think as far as HPCL is concerned, I think we are also gearing up for the energy transition, and to become, we have declared we would be a carbon neutral by 2040. I think various initiatives have been taken on two fronts. One is on the business front, and as well as on the R&D. I think, we are positioning ourselves from being a petroleum company to a petrochemical and energy company. So having said it's an energy company, I think definitely it's very important to work on energy storage materials, to work on hydrogen, fuel cell, and other technologies. As far as battery is concerned, I think I'm giving the overall idea of areas which we are working on. I think the relevant department, if they find something which is interesting or which they feel they can contribute for HPCL journey, definitely we are welcome. We can have a separate round of discussions with them. So the first is, I will start off in the chronological order what we have done. We have started with battery department. We are currently working on lithium-ion battery because lithium sets the benchmark. What we do in lithium, we have to understand the lithium technology in totality, be it commercial material or our own materials. We have made our own India's first rechargeable coin cell, which works for about 400 charge discharge cycles. We have also made a 5 ampere hour pouch cell, in-house cell, which is being tested currently for 300 cycles, and then I think that it's on its journey. The learnings of the lithium are being put into in the sodium development of sodium ion battery, because there are a lot of concerns on lithium. Availability of lithium is a concern. So we are migrating gradually from lithium to sodium after understanding what's exactly happening in lithium. We are also working on supercapacitors. I think these are high power devices, but of course low on energy. We have activated petcoke and made India's first 1200 farad supercapacitor along with the ARCI. We are also working on vanadium redox flow batteries. Since we are transitioning from the petroleum company to an energy company, definitely we need to have all the technologies to store renewables, which are intermittent in nature. So we are working on vanadium redox flow batteries, specifically meant for stationary energy storage applications. We expect vanadium is a concern, but I think we will get vanadium from the crude oil. That's one thing. And then we are also working on various energy materials which are required for future. So on hydrogen as well, I think we have placed India's first order for an green hydrogen plant, which is an alkaline electrolyzer. It's a 2.6 megawatt, which is currently being installed, which will give about 500 normal meter cube of hydrogen per hour. We are also working on blue hydrogen, where we put methane and the products are going to be hydrogen and carbon nanotubes. That is ready for demonstration in our R&D center, and it's going to be installed in one of the retail outlets. We also have technologies for hydrogen PSA, pressure swing absorption. I think we are the third company in the world after UOP and Linde to have these facilities. Last but not the least, I think the next is going to be the fuel cell. I think that's going to be the project of national importance, where we have tied up with CGCRI. I'm repeating it again. I think the third person who is going to tell about this project. It's a 70 crore project. I think we have been working on this project for 1.5 years before we got the final approval. But the standards which have been set for these projects are benchmarked with DOE standards. Whatever DOE standards are there, we have kept those as the benchmark, and we will be we signed the MOU on 3rd of May. And CHT is going to give about 35 crores. HPCL on its side is going to invest about 35 crores. Considering all the limitations which the other fuel cell technologies have, I think SOFC is a technology which can generate green power with commercial hydrogen. I think that's the key point. And also you can, it's going to have an internal reformer and an external reformer. So we can also operate it on methane. That's the whole ambition with which we are moving. From the TRL 4-5, which CGCRI has achieved under the leadership of Dr. Jayanto Mukhopadhyay, I think we would be scaling it up to TRL 7. Finally, we will be using this technology for as a replacement for DG sets for stationary applications. We would also use it for cathodic protection and also integrate it with the stack of our refineries. I think we are on the journey. I think we are on track. We will definitely surpass the goals which have been set in the project proposal, both in terms of the scale and the speed. And I think we would not call it benchmark anymore. I think we will call it the next mark. And I'm hoping for a lot of collaboration with CGCRI. And thanks for all the support. It has been a great team with CGCRI Energy Department. And I think we can explore possibilities of opening up other projects as well, like for example, solid state batteries and other things. If there are some constructive proposals, I think we are ready to chip in. But we would like to enter when the TRL levels are 5 or 6 and not at the lower TRL levels. Thank you.
Thank you, sir. Uh,
Good afternoon, everybody. Myself, Dipen Dubey, and my senior colleague, Mr. Vishwanath Mukherjee, is present from EMI Limited, Kolkata. So, EMI Limited we started in 1932 in India. So, for last almost 90 years, we are completely focused in instrumentation and we are providing solutions in many business verticals. So, our core competency is in civil and infrastructural monitoring, as well as the condition monitoring of the key assets in industries like steel, power. We are also very much present in aerospace, defense, and electronic industry. So, for the past couple of years, we are in structural health monitoring of large civil infrastructure like bridges, railway bridges, road bridges, dams, and large in domestic buildings or industrial large structure. So we have found that fiber optic sensors has very good application in this area. As of now, all the sensors are being imported outside of India. Now we are in discussion with CSIR for an effective collaboration with them so that we can manufacture all these sensors, fiber optic based sensors in India itself, and can implement those for our organization.
Thank you, sir. Dr. Bhaumik.
Good afternoon, everybody. Myself, Dr. Sudhir Bhaumik, technical director of on a group of company. So last 20 years, I am working on water treatment, mainly for the elimination of arsenic from contaminated groundwater. It has been learning from Germany. For its technology is adsorption. Adsorption technology is costly because I have to import is a very hydroxide, annular very adsorption. So now we are the partner of this CGCRI and trying to do some ceramic technology for the elimination of iron, arsenic, and wastewater treatment as well. So I hope I will get associate with your organization and support from your organization for
Thank you, sir.
Good afternoon, everybody. This is Shobhana Ghosh on Lila Agrotech Private Limited. Actually, last 20 years we were working in the agri-tech industry, and we are the largest manufacturer of biofertilizer in West Bengal, and the largest manufacturer of vermicompost in Eastern India. So here we are working with CGCRI for last 1 year regarding on research, because we are also associated for so many research work like waste recycling. We have done successfully. There are so many waste recycling work with Goodry Group, with ITC, and so many companies. So this project is going on, and it's an things is going on with the biochar, the electrolysis companies making their waste. And we are finding, some fortification to be done with that biochar because mix is present in there. So we are hopeful that we should work something and that will make that waste local. Thank you.
Good afternoon, everybody. Ajal Shankar Secretary. I'm with Almaty's Alumina. We are alumina raw material manufacturers. So, was in very few minutes. We are fortunate to work with CGCRI in some projects not in material development but in application development for understanding the market and how better to utilize and optimize the application of the material. So the positive point of working with CGCRI lab and scientists I found is that the understanding, the technical understanding is clarity in technical understanding. And the other part is when you start a project, you are not only conversant that how things will move down the line. Right? So the flexibility in the course of action, that I found a very interesting point in working.
Thank you, sir.
Thank you very much.
Good afternoon to all. I'm Shaktashi Sangupta, representing Hindalco, and particularly the alumina chemical business. We are present in the solution from traditional markets such as refractory ceramics and water treatment chemicals, fire retardants. We are also working in very advanced markets. We are trying to develop solutions like 3 and 4 and alumina, some of which goes in the sensors, as a substrate in the electronics, and further on in many other applications. We, in fact, Hindalco as a company is, as many of you might be knowing, is one of the most successful aluminum companies globally. So we are also working on the many of the sustainable solutions. As you have mentioned in your presentation on the particularly you work on emission reduction. Even we have our own target for reduction of our emissions, and those work is still ongoing in our company. So we look forward to working with CGCRI in collaboration with on these solutions and also on the advanced solution along with the traditional works for traditional value addition in the industry what we are doing. Thank you.
Thank you. No, this side. Sambuddha. Wait, sir. Sambuddha.
Hello, myself Shobhuja, representing Prison Johnson Limited. I am very thankful to Shaksha sir for this invitation, and it was a very good session overall. So we are actually associated with CGCRI for a very long time. Through ceramic membranes, through radiation shielding glasses. So there are many projects that we are actually associated with CGCRI. Associating ceramic membrane division. So to be very precise, I would say that Indian markets like water treatments is the fraternity, water fraternity for the last 14 years. So water treatment today means a revolutionary change where the cost of treatment as well as the effectiveness of the product and the output of the product matters. Most of the plants which are actually running in India or are actually working in India doesn't function to that extent to which it should function. The major reason being the inlet parameter changes and outlet parameter also changes at some time. So ceramic membrane is one such product which we are manufacturing along with CRI through technical collaboration, and I feel that it has got a very good vibe or the magic to prove its effectiveness. There are many range of products, and my honest request to CGCRI would be like since water treatment involves like microfiltration, nanofiltration, as well as reverse osmosis membranes. So those are mostly polymeric membranes or conventional membranes that are being used in today's date. So I would request CGCRI they can develop more reduced pore size ceramic membranes so that we can also enter nanofiltration or reverse osmosis. Thank you.
Sir. You.
I am S.N. Daha from Natasa Ceramics. There was a scientist over here. In 73-74, Dr. Sina was that time the scientist over here. He talked about the glass fertilizer. And he showed us that any type of fruits or these, if you use glass fertilizer, it will be very effective. Because normal fertilizer like urea, these they get dissolved. 10% of fertilizer are used for the trees or any sort of plant. But glass fertilizer, particular composition, whether a certain nutrients required for the trees.
Well, sir. Well, noted, sir. Noted.
This work is done when again, last fertilizer, I think that will be a revolution.
Sir, can you be brief, sir? We are running out of time. Yeah. Next, anybody? You, sir? So I think no other industry participants are there. So that concludes. I really thank all the participants online and offline for their valuable comments, and also our two centers, Purja and Naroda, those who are scientists are attending, staffs are attending this industry meet program. We have certainly noted down your valuable comments. We will see these recorded sessions and one-to-one. Our interest will express to industries, and industry also can approach us through mutual discussion. We can arrive at more collaborations. Now I request all the invited industry guests to kindly proceed for lunch in the dining hall adjacent next one. And if have a vehicle and driver, so please let me know. So lunch for vehicle drivers are also arranged, so kindly let me know. So we conclude the industry meet and let us proceed for the lunch. Thank you very much. The industry participants only kindly proceed for lunch.
লিভ করছে স্টার্ট করছি না, হয়ে গেছে, সব হয়ে করে দিয়েছি, স্টার্ট করতে যাচ্ছি না। ঠিক আছে, আমি যখন উঠলাম তখন তুমি চলছিল। ঠিক আছে, কনফার্ম হয়নি। বলছি আর কিছু কি আছে? তাহলে আমি ইনস্ট্রিম করে দিচ্ছি, কিন্তু ইনস্ট্রিম করলে কিন্তু আর লগ ইন করা যাবে না। হ্যাঁ, আর তো কিছু নেই, কনফার্ম হচ্ছি আমি। ঠিক আছে, হ্যাঁ মেরে দিচ্ছি। ঠিক আছে, ঠিক আছে।